Quiz2 question paper March 16, 2025. What is the impact of using a sigmoid activation function on the gradients when the input to the neuron is a very large negative number? So input to the neuron is a very large negative number. Neuron Y is the output, X is the input. When the input to the neuron is a very large negative number, the input is a sigmoid activation function. Z, that is sigma represented with Z is the input. So how do we write the function represented in terms of Z? So that is 1 by 1 plus e power minus Z. Z is the input. This is the function representation of the sigmoid activation function. Means, so what is meant by gradient? Gradient is differentiation. So d by dz of sigma of z. That is partial differentiation of the sigma of z. That is sigma dash of z. That is, it represents the first order derivative. Sigma dash means first order derivative. That is the function of sigma of z times 1 minus sigma of z. This is the derivative of the sigmoid function. Neuron is a very large negative number. So given the z is a large negative number, for example z equals to minus 200. For example, large negative number minus 200 is equals to 1 by 1 plus e power minus of minus 200. That its value becomes 1 by 1 plus e power 200. So that is e power 200 is approximately large number, very large number, that is infinite value. So that is 1 by 1 plus infinity, large number. So infinity equals to 1 by 1 plus infinity is also infinity. So what is infinite value? Infinity equals to 1 by 0, right? 1 by 0, that equals to 0 by 1, that equals to 0. That is sigma of z equals to 0. A large negative number, sigmoid function value is 0 of z, that is first order derivative. So you have to put sigma of z equals to 0 in this equation. That is 0 times 1 minus 0, that is equals to 0. That is sigmoid value is 0 and its derivative is also 0. Sigma dash of z is the gradient. This is the gradient. So that is gradient becomes 0. This is called when gradient equals to 0, that is, this is called the vanishing gradient problem. Vanishing gradient problem. Because of this, we are replacing sigmoid activation function with Rayleigh activation function because of vanishing gradient problem. What is vanishing gradient problem? The derivative is value is 0. So that is the input of the sigmoid activation function. That is, for the sigmoid activation function, the input is large negative number or large positive number. So if the input is large negative or large positive also, it becomes 0. Output is 0. That is this value, sigma dash of z is 0. So that is output is 0. So this is called the saturation. So what is meant by saturation? For the input to a sigmoid function is a large positive number or a large negative number, the output approaches to 0 and gradient becomes nearly 0. Output and the gradient both becomes 0. This is called the sigmoid saturation. Sigma of z saturation becomes slow. Learning rate. Learning becomes slow. So the answer for this question is the output approaches 0, that is sigma of z approaches 0, and the gradient is also approaches 0, that is sigma dash of z is also approaches 0. Both are 0. This look like this sigmoid function. This is sigma of z, value up to 0 to 1 between the output of the sigmoid function, that is the output of the sigmoid function is between 0 to 1 value. This is the derivative function, very important, you can remember. This is sigma dash of z, that is the function in terms of sigma of z times 1 minus sigma of z. So its value derivative here, the saturation region. Saturation means sigma dash of z equals to 0, that is derivative is 0 here also. So derivative becomes 0. So and this maximum value for this derivation, that is sigma dash of z, the maximum value is 0.25. This value is also important, you can remember. 0.25 maximum value. This is for minus infinity, this is for plus infinity. In this region the derivative becomes 0, equals to 0. This point is origin is z equals to 0. Thank you for watching. If you like my videos, please like and subscribe my channel.